So we put on, one of the technologies we do is a diesel oxidation catalyst. This is a flow-through type of technology where the exhaust stream of the diesel exhaust goes through a ceramic substrate or core. That core is then wash-coated with precious type metal. There's a chemical reaction that occurs. It's a flow-through technology. We talk about particulate matter, PM, the reduction of PM, and that is roughly about 20 to 30% depending on the engine output of reducing that PM. There's other technologies out there that can reduce up to 85%. That's not what we're talking about here. And we're really looking at the legacy fleets to retrofit. Fuels, it can work with a B20 biodiesel blend up to 20%, and then also the ultra-low sulfur diesel fuel. And then way back in the beginning when we started retrofits across the country, the low sulfur diesel fuel was the only fuel really available, but since 2006, with the introduction of ultra-low sulfur diesel fuel, it can run on all those different fuels. So what is particulate matter really made up of? With the diesel oxidation catalyst, this is kind of a pie chart that we show, and the breakdown of what a PM particle might look like, and this is just really generic. And this is actually from low sulfur diesel fuel, so not the ultra low, but what we really look at is this lube and the fuel SOF, soluble organic fraction SOF, and that's the unburned portion of the fuel that we're converting to a more user or a friendlier gas. So that's what we're after when we are putting the DOC onto the school buses. So what does the DOC look like? It has to be a verified product. When we talk about verification, we talk about CARB verification, California Air Resources Board, or EPA, Environmental Protection Agency, where it has to go through a series of tests on our end, a field test, and then they look at the data and the package that we submit, and they have to agree to verify that product. So it's a pretty long process to get a product verified. What we're looking at is doing the legacy fleets up through 2006, and then beyond. So it's a replacement for a current muffler on a bus or a vehicle. So you take the old muffler off and you replace it with the DOC muffler. And it also is a maintenance-free type of device. So we have pre-engineered a bunch of different configurations and kits. So when we provide product to the school districts or to the installers, we've got kits, we call them school bus kits, and this is an example where we've got an inlet section here where we've got an inlet clamp. We have the brackets that hold it onto the frame rails, and then we have the outlet clamps as well, and then the assembly of the DOC. And this is just a picture of one that's installed on a school bus. So it's really can be almost a drop-in fit for the existing muffler. I put this slide together just to show that we're not offering a DPF, a diesel particulate filter, which is a retrofit device that can go on legacy diesel engine fleets as well. But this is a product that is a wall flow, where the exhaust flow goes through the ceramic wall and then captures the majority of the particulate matter up to 85% plus. So they're really about 90% efficient. So we're not talking about this for the Project Green Fleet program, at least not yet, being offered, but it is a technology that's out there that we are retrofitting across many other states. In California, it's mandated to retrofit their legacy fleets with this type of technology. So the other technology is spherical, or crankcase filtration system, where we're taking the blow-by and we're closing that 100%. This is an example of a crankcase filtration device, spherical. This is Donaldson's system here. And it has a replaceable filter, but it's actually taking 100% of the blow-by gases and capturing them and then cleaning the gases, and the oil is coalesced back into the engine, sump through the drain tube here, and then the clean air goes back into the engine intake system. And if I can start this just as a representative of little animation slideshow. So what's taking place here is this just kind of an animation of a diesel engine, and that top tube here is the exhaust fumes coming out of the blow-by gases, which are very it's open to atmosphere, and this shows the cylinder going up and down with the exhaust valve and the intake valve. On the top end of the engine, you've got this unburnt or burnt fuel or gas, and that is open to the atmosphere that goes into the tube, and is what we have found and other people have found with that gas, and that those exhaust fumes and those emissions, that it actually comes right back into the school bus cabs. With the engine being a front forward type of engine, that has the ability to go right into the open door of the school bus. So what we've developed is a spherical unit, post-crankcase filtration. And with this, same type of scenario here, but we've actually added, this is actually an open system as it shows here, but then it goes away and it'll represent a closed system where the filtration takes place and we bring the clean air back into the inlet of the air cleaner. So as the fumes are coming off the top end of the engine, they enter into the inlet port of the spherical. Those particles get and the gases get coalesced and filtered, and and the coalesced oil goes back into the sump, and the clean air gases go back into the intake system of the engine. So we're 100% closing the crankcase on using the spherical unit. It's a replaceable filter. The replaceable filters can be replaced about every 1,000 to 1,500 hours is what we talk about, but it really is dependent on the duty cycle of the engine and then the amount of mass carryover and blow-by that is seen on each of the different individual engines. Here's a photo of an installation up next to a firewall someplace. So this is shown right up here next to the firewall. We don't drill into the firewall, we use existing mounting studs to mount that. And we've also pre-engineered a lot of these kits too, and with the components, and this is just a schematic drawing of what that installation would look like. Here's the body of the spherical, here's the hose back into the intake system. There's actually a bypass valve, and then we also have an indicator that will tell you when to change the filter. So with that, dirty diesel, yikes. And this